I do a lot of work in pulp and paper, people don't realize just how many pulp paper facilities there are in this country. And there are over 500 different pulp and paper manufacturing facilities in this country. And so to support them, it requires a huge effort because there are so many different environments within pulp and paper itself. Because you have, if it has a bleach plant, then you're looking at essentially a chemical plant on site. You know, shipping and receiving, railheads, and then you have water treatment facilities at a lot of these places. So you have a lot of dynamics, different dynamics, all involved in one gigantic facility. So this particular one, their shipping warehouse also happens to have a railhead inside of it. So, you know, I was dealing with a lot of train cars and different things like that inside a building. But even then, something you need to take into consideration is this building, even though it had roof and walls, was still exposed outside. So, and it's down south and it's coastal, so it's dealing with high heat, high humidity, salt air, all these various corrosive things. And to give you a better idea, this is what it looks like from above. And you can see in this area here, this is the brown stock storage warehouse. You can see a lot of rolls actually sitting outside, stuff that didn't make the cut, so it will turn into recycle and go through the entire process again and become new rolls. And then this long portion of the building here, you can actually see the rails coming in. This is an indoor railhead, so it constantly has train cars being moved and out, loaded, unloaded, and things of that nature. So it's a lot more of a hostile environment than one would associate with the phrase shipping and receiving. So when you go inside, this is what the warehouse side portion looks like. You have your ceiling grid, which is approximately 25, 28 feet high, and then it peaks on the ceiling about 35 feet. It's all corrugated steel. The concrete floors, you know, heavy steel reinforced concrete flooring. And then when you look at all your giant rolls of brown stock sitting everywhere, what this translates into is an absolute terrible environment for wireless communications.
The thing I was thinking about is like, wow,
yeah.
Metal all over the place, paper.
Well, between reflection off of all of your metal surfaces and your concrete surfaces, and then all of your absorption from these gigantic rolls of brown stock paper, and you know, if the Wi-Fi is not getting sucked up, it's getting, you know, bounced all over the place, which results into what we refer to as multipath fading. And that just makes it that much more difficult for a client device to maintain a solid connection with all of the retransmits that end up happening in a situation like this.
Mm-hmm.
So you take this situation and you complicate it one step further by lowering your ceiling by about 10 feet and then cramming a bunch of steel train cars down long, narrow alleys, you know, and then expect your fork trucks that are running around that have small tablet devices with scanners on them, expect them to have the full ability to be able to scan wherever they are within these rail lines, you know, and this side was even more hostile in the fact that there was no absorbing factors. It's just all pure reflectivity through all of this. It's absolutely, it was crazy. And so the results are just inconsistent connectivity all the way through. So when I fired up Air Magnet and I did my walkthrough, some kind of strange things came to light, and let's take a look at that. So these were the floor plans that they gave me, and I was able to go through. And this is the 2.4 passive survey. And when looking at it, you know, well, you know, hey, there's lots of green. It must be great, right? Well, again, going back to what we were talking about with reflectivity, a lot of this green was essentially a false positive as far as its signal strength was considered, due to all of that reflectivity. Because when you were trying to maintain a connection furthest down at the ends of the railhead, there were constant drops and reconnects. So even though it was seeing, the overhead was reporting that there was signal there, there wasn't necessarily quality signal to pass data on. And so again, while from a quick view, well, it looks like it's covered, but something kind of struck me as a little weird, and I'm going to use the warehouse portion as an example. When I went back and I actually looked at where the APs were placed in the warehouse portion, things were just struck me as kind of odd, because if these were the placements of the access points, why are, and they're using Omni antennas, why is all of the coverage almost in a directional fashion? You follow me?
Yep, that's interesting there, indeed.
Yeah, so I had to go back and take a second look and see what's going on, because this doesn't make any sense, you know, especially with the placing of the access points. So already Air Magnet was cluing me in on some of the oddities that were going on in this facility.
Scott, so there's a question here. So how, you just looking here, how do you figure out it was a directional signal?
Well, and again, when I first glanced and I walked through, and I've got another picture here that I'll show you, at first glance, I saw that they were actually Omni antennas sticking out from the install points, which is why when I went back and verified the actual install locations of these radios, and then seeing all of the signal here is really blasting more to one side as opposed to a nice 360 around the mounting location, that just struck me as wrong. And on my initial walkthrough, I really wasn't paying attention at the ceiling as I was trying to not get run over by the fork trucks that were kind of running around there, because that's a big safety piece too.
Yeah.
You know, I'm wearing my day glow vest to make sure nobody runs me over. I've got a guy walking ahead of me, you know, so there's a lot going on in one of these facilities. So a lot of times you have to do a second or a third walkthrough. And so what I discovered when I was looking up at these radios, first, the radio here is it's an old Cisco access point. It's actually, these APs are actually 4 or 5 years beyond end of life. But they have these, you know, nice long antennas, and these are obviously omnidirectional antennas. But there's a couple things wrong here, okay? So first, when you take a look at an antenna this long that's 2.4, one of the dead giveaways is the fact that it's a high gain antenna, all right? So when you look at your radiation patterns, on an Omni antenna that's say like, you know, 2, 3, 4 dB, you get this nice wide beam width that covers a lot of area, and that's what you want out of an Omni antenna. You start increasing the gain on that to say a 7, 8, or 9 dB gain antenna, it starts to flatten out your beam width, okay? And so problem number one is they've got these they turned out to be 9 dB 2.4 Omnis mounted up. You know, so already they're actually losing coverage space because the majority of their coverage is up high. These mounting points are approximately 25, 30 feet up in the air. So they were already missing, you know, everything down on the floor to a degree. But the other big problem, you spot the problem with these, Julio?
Let's see here. Is that like they're pointing on to the side or something?
They are actually mounted at a 45-degree angle. So not only are they using the wrong antenna types, but the way they have them mounted, and this is why I was seeing all the coverage down below almost, you know, only to one side, because it was 2/3 of the coverage of these antennas is being, you know, just essentially shot up to the ceiling of the facility. So all of your strongest areas were down and lower and behind these Omnis, whereas all the rest of the coverage was just contributing to more of the reflectivity and the multipath fading that was going on. And it wasn't just this one radio, it was all four. And then on closer inspection, when looking at it, half of these antenna connections were corroded, and one actually kind of fell off
Wow.
while we were inspecting it. You know, so that also goes back to the environment, that even though it's considered indoor, because it's still exposed to the elements and the heat and the humidity and the salt air, all these factors play into the demise over time of what they had installed, let alone the fact that it was actually installed incorrectly.
Yep. So a few questions here. We're getting lots of questions. So first one, Ari, to your question about the light blue converging in the middle when we saw the heat map earlier. Yes, there was a tip there where you could see that you had all the green, then you had the blue, but the blue there wasn't really like an omnidirectional shape. It was just like pointing towards one side. That gives you a hint that the signal was stronger one way only, or basically directional. Also, regarding your question, Scott, about, hey, what else doesn't look right in here? Steve is saying if maybe the antennas were just like too close to each other, would that also be a problem, or the spacing between the antennas there?
I don't think the spacing between the antennas was really that much of a problem, because usually you want to keep at a minimum of 6 feet, and these guys were about 10 feet apart. So I don't contribute their spacing really to the overall demise of wireless in here. You know, that is that's a good point though. That is one of the things I did look at, because I wanted to make sure they weren't too close, because typically a lot of these, if they're installed by people who don't have any experience, they'll just put them right next to each other, you know, and that, or they'll run them directly off the radio, and if they're not designed for that, then that can also cause problems.
Yep. So then one more question here, well, two more questions here. So Ari is asking, would it make sense to mount them maybe at 5 degrees the other way instead of 45 degrees this way? Like, for example, so.
Well, when it comes to omnis, I mean, these are dipole antennas. They are meant to be mounted vertically. That's what they are designed for. They're not designed to be mounted in any other fashion, because it alters the coverage that they were designed to project. And that's really all I can say about that.
That's a very good point. And the last question, let me scroll up in here. We've had so many questions that I lost it. And I think I can help with this one. So the question is from Christopher. How do you plan to survey in the Wi-Fi 6 space? This time, the G2 and NXG don't offer the solutions. And well, that's the answer there, it depends. You are correct, both the G2 and NXG have a Wi-Fi 5 radio. Still, if you're doing passive surveys, like in the case of Scott here, that really doesn't make much of a difference, because we're looking at basically beacon frames, which don't change with Wi-Fi 6. In the case though, if you were trying to do an active survey, that's where you will see a difference. Mostly because if you could connect and try to measure throughput, you'll be basically connecting at Wi-Fi 5 data rates. So it depends on your use. If you're like Scott doing passive surveys, and even an N radio would work. So the G2 and NXG will be more than enough. If you're doing active surveys though, another option that Scott also highlighted, you could use the Air Magnet Survey Pro software, which has support for Wi-Fi 6 radios. So you could use, for example, an Intel AX200 or 201, for example. And I think at last I saw, I think it was Edimax. Well, one vendor out there, they just released a couple of weeks ago.
Yeah, I think it was Edimax. I've been using the Edimax that AC 1750 forever, because it's just been such a great adapt. I'm actually on my second one. My first one got got busted. So, anything
That,
from that side, I tend to hold in high regards. And that's what I was about to say too.
I think they have a new one called AX 1800, which is the AX version that came out
is that what
recently.
it is?
Yep.
Wi-Fi 6 is just coming out, and it's going to start spreading out in the public sectors and in the private and education. It's going to take a while before it starts filtering down to industrial applications. Wireless is just now, in the grand scheme of things, over the past 5-6 years, actually really taking off as a trusted means of communication in industrial environments. So industry tends to be slow adopters on these things because they value reliability over security and over every other factor. So wireless to the industrial world hasn't really proven itself until relatively recently. And so again, that slow adoption rate tells me that we've got time before that starts expanding, before Wi-Fi 6 starts expanding into industrial applications.
Yeah, very good point. So one last question here before I let you move on. So this is from Jeff. Do electric motors on what are probably a lot of fork trucks cause interference as well?
That is an excellent question. I would say I have yet to find any fork trucks that cause EMI or enough EMI, electromagnetic interference, to disrupt wireless in those particular frequencies. But in the next situation that I get into, I will show you an example of where EMI absolutely does interfere. And this is why I use so much spectrum analysis in industrial applications, because you absolutely have to. But as far as your question is concerned with fork trucks, both electric and propane, I have yet in my personal experience to see any of those actually interfere with structured Wi-Fi.
Okay, great. Well, thank you, Scott, for answering all those. So I'll let you move on.
All right, so so now I move forward to give them well, and before I go any further, this is what their 5 gigahertz look like. So their tablet devices are newer devices, and so they are 5 gigahertz capable. And part of their problems when looking at the logs of their devices, they were trying to change over to 5 gigahertz when they see it, but then they would get dropped as they zoom around because there really wasn't any solid roaming abilities for 5 gigahertz through the facility. And those 4 APs that I've showed that were in the warehouse, as it turns out, they weren't even broadcasting at 5 gigahertz. They didn't even have those connected up. So, those tablets, as far as connecting on 5 gig for roaming, were doomed before they even started at that point. So really what you have overall is an older deployment that wasn't fully planned out properly, and then just fell apart over time due to environmental variables. And there were actually several APs I found that were hit by fork trucks that were damaged, that weren't even broadcasting. One was full of water. So, you really got to pay attention to all this stuff, because all these parts come together to really make it difficult for any of this to work right, period. And let's face it, Wi-Fi is magic anyway, right? So I fired up Air Magnet, and I essentially created them a new design using their Cisco shop. So I was able to look up an outdoor Cisco AP specifically for this application. And the nice thing about this is that a lot of people like to use external antennas for applications like this, but I try to use the appropriate internal radios with internal antennas whenever possible, especially when you have a lot of moving vehicles throughout the area, because that avoids a big portion of damage that can happen to them. And within the inventory of Air Magnet, they actually had the propagations of the radio I was looking to use, so it was nice. So I know that these patterns are reliable because these are the actual radio patterns from Cisco. These particular radios, moved them away from using indoor radios in here because, like I've already talked about, this is really an outdoor environment. And so I was looking at these outdoor Cisco radios, And these particular radios actually have a 30-degree mechanical down tilt built into them. So while, you know, it does have their standard omni pattern, it's also pushing down more of a cone as opposed to losing half of your coverage up high, which long run provides a more stable environment for vehicles that are roaming all around the facility. I was able to go through and set my attenuation values for all the walls. I was able to set different attenuation values for different areas within the facility. And so the overall turnout for the 2.4 design, I was very happy with. And one other thing with their prior, what they had active at the time, everything was cranked up to full power. So all of these APs were broadcasting at their max ability, which I want to say was, gosh, I want to say close to 30 dBm. I want to say it was 28, 29 dB. You know, so broadcasting full power, which all that does is really increase the reflectivity of everything. But the additional side to that is the tablets that they're using were only capable of a max of 22 dB on their RxTX receive sensitivity. So they were having a hard time connecting up anyway because they had to be a certain distance away for those power levels to match for that communication to happen. So this new design, I dropped the power levels way down. I want to say they're around 15. I think I've planned for 15 or 16 dBm throughout the facility. So that, number one, gives the devices a much easier signal to connect to. And two, you know, dropping that power level really helps you control the reflectivity that you overall can't control. So if you can't remove something that's causing that reflectivity, you can at least drop your power to make that reflectivity become less intrusive to the other devices that you're going to be using throughout the facility. Overall, I was very happy with the design. The client was very happy, and they are actually, they have procured the APs and they are moving forward with this new design. And they actually, I actually have to go down there the week after Thanksgiving to help them get the final configuration, and then I will do a follow-up survey on this. So I should have some good information after the fact.
Nice. Looking forward to see the results.
And then now I also planned out their 5 gig. Their 5 gig was very solid. And one thing I got to say is I concentrated coverage on all of the areas of where their fork trucks are going to be roaming using these tablets and scanners. There's a few areas that are a little bit lighter, but those are areas that the fork trucks don't get into because of the stock that's in the way. Every location that the fork trucks could possibly go to need to scan product before moving it, they at bare minimum are seeing 2 APs at neg 67 or better. So overall, again, very happy with how the design turned out, and obviously the client is too, because they're in the process of remediation.
Nice. So Scott, a few questions, and one of them is related to the signature they're seeing down on the floor. So first one is from Eduardo. I've seen that APs in warehouses are at times placed very high up in the ceiling, 22 plus feet, for example. And this causes the signal reading at the floor level to be around minus 77 dBm, for example. Yes. Because APs see each other on the ceiling and decrease power to minimize CCI. Any pointers on how to address this?
Okay, that's a fantastic question, and that's one of the reasons I try to find radios. If I'm going to use internal antennas, I try to find radios that have that 30 degree mechanical down tilt built into them. That usually will give you a good, I don't know, 5 to 10 extra feet in mounting height and keep that signal down low. But in a lot of cases, I've had to use drop mounts. So you figure Cisco's, if I'm correct, Cisco's rule of thumb is 25, 30 feet is about as high as you want to mount theirs. After that, you start losing connectivity for exactly what you're talking about. Aruba is, I talked to one of their engineers a couple weeks ago. I want to say Aruba is about 40 feet, And it's because they use that mechanical down tilt in almost all of their APs, as far as their omnis are concerned, that aren't specifically designed for outdoor applications. So between mechanical down tilt that's built in, and then using drop mounts, which are essentially poles that you can then just hang down from the ceiling and mount to, so you can adjust your ceiling height. But in a lot of these situations, you also have to be cognizant, is there going to be machinery moving around? Are there going to be people driving around? You have to make sure that you're out of range of anything that's going to be going up high and grabbing things. So, but personally, what I've done, again, those two things is using the drop mounts helps. And then when it comes just to storage warehouses, you have to use your storage shelves to your advantage for their attenuation for that exact reason. So to help keep your APs from seeing each other directly, and then essentially combating for airtime that's not even being used up top. So
Nice.
Does that make sense?
Yep, yes, it does. Thank you very much for that. And there's one more question.
I start rambling sometimes, and I don't mean to.
No, that's okay. So there's one more question regarding EMI, but I know you're going to talk a little more about that in a few, so I'll put that on hold. And so one more question before we move on from Ari. So you mount on the steel pallet racks?
That depends on, it's going to be different for every site that you go to. This particular site, their old stuff was mounted directly to the metal beams. The new, they have a different group doing the installation now, and they're actually mounting horizontal boards that then they're going to mount the radios to underneath. Okay, but again, that's different for every location. I have been to some locations where we have mounted directly to the beams. Well, let me correct myself. We actually mount the radio mounts to the beams and then lock the radios onto those mounts. I haven't had a problem with that in general, because typically the minor reflectivity that causes is way up high, and that's not where your devices are anyway. And it's faded to the point where it doesn't really make a difference to your end user devices, that are 30, 40 feet down lower. But again, that's been my personal experience, so I can't vouch for everything.
Yep. Okie doke, Scott. So those are the questions for now. I'll let you move on.
All right. So our next place was a roofing and insulation manufacturing facility. These guys got in touch with us because they were having some terrible, terrible problems. So they were complaining that they were having multiple connection issues. Again, this was another place that was a mix of warehouse and production facility. So they had fork trucks running all over the place, moving stock from production to storage and vice versa, as well as shipping. They were complaining that their wireless communications to local on-site services was very, very slow. Even though they were showing like strong signal connections to their devices. And then their other software that they had to connect to, their management software, which was offsite, was hardly usable. It was having a really difficult time maintaining that data connection through. So, even before I got there, I had already put together my plan. So as soon as I got on site, the first thing I wanted to do was go around and talk to all the guys on the floor and all the everyday users and see what their experiences are really like. It's one thing to hear something from the guy who's trying to get you to come out there and check it out, but it's a different ballgame when you're actually talking to Joe, fork truck driver, who's actually doing all the work, using these devices to try to get his job done, and facing the frustration when it doesn't work. And then I wanted to go and gather all the information I can about the devices they're using, referred to LCMI, oh my gosh, least, wow, my brain just, anyway, the LCMI devices, least compatible, most important, or not compatible. Oh, I'm sorry, it's least capable, most important devices. So your weakest devices that they have to use on a daily basis, and it started gathering all that information. And in this case, it was actually a mix of Zebra and Motorola handheld scanners. and then some other tablets that were mounted on their fork trucks as well. And that's important because you have to know what those capabilities are to see if the wireless is even capable of matching that. And then, like before, get in there and get a passive validation survey done so you can actually see what's going on in their environment. And then some spectrum analysis. If, you know, there's a lot of machinery, we were talking about possible interference things, and this is where things get really interesting. So, you know, this is the facility, and they have multiple production lines over on this side. So it's 1, 2, 3, and then they have essentially a chemical mixing line over on this side. And then they have over on this side, this long line there is a curing machine. And there's all sorts of products stocked all through here. That as it comes off the lines, that's where it's stored temporarily before then it's moved over into the warehouse. So there's a whole lot going on in this facility. This facility is probably 800,000–900,000 square feet. It's a big place. My initial run through with my passive survey was really, really strange. This did not make any sense to me whatsoever. Because before I even started, I verified that all of their APs were up. I have verified that all of their APs were broadcasting both in 2.4 and 5 gig. I couldn't get a really close-up inspection because in this location, we're not talking about 25 feet ceilings, we're talking about 40 feet. So it's way up there, and you know, there wasn't a lift available to go running around in. Nor was there really the ability, because they're in a full production swing, because they run 24/7. So, you know, there's some white spaces there. Obviously, it's because I couldn't get close enough due to product storage and everything of that nature. But as you can see, there are these giant gaping areas where there's hardly anything. Yet 2 or 3 feet and 4 feet in another direction, you're getting like this golden amount of signal that is what appears, you know. And this is a good example of this area right through here. You're just seeing nothing, but then, you know, a few feet in the opposite direction, you're getting what appears to be decent usable coverage. And again, this is very deceiving because you have areas that look like they should work, but they don't. And then you have these just huge gaps in coverage that should be there. Now, when you compare this to, and you can actually see everywhere I walk, this one has all of my little my trails that I walk through, the little happy guy going. But when you compare that to 5 gigahertz coverage, it's a completely different story. Okay, so something was going on in the realm of 2.4, and it turned out most of their devices were older devices that were only 2.4 capable. Because I was like, well, why haven't you just moved over to 5 gig? Well, we can't. So after much investigation and walking through and checking things out, things just weren't making sense. So I had to break out my spectrum analysis. Okay, I use Channelizer. That's my spectrum analyzer of choice. And for those of you who aren't familiar with spectrum analysis, this is kind of what you look for and what you hope to see in general. Without doing a deep dive into it, you just want to see nice, pretty blues, maybe a few greens and yellows. You don't want to see much in the way of channel activity being eaten up and whatnot. So this is kind of a normal view of what you hope you see in an environment like this. So, but that is not what I saw in 2.4. This is what I saw in 2.4, which absolutely blew me away, because I have never seen anything like this in my entire life, as far as just overwhelming, mechanically produced interference. So this is what is referred to as non-Wi-Fi interference, because it is just this noise that is generated in that spectrum. And you can actually see it's kind of a nice little sine wave, really, that's going up and down through the spectrum, and it actually bleeds over into 2.3 and then further up into 2.5.
Yeah, that's a very interesting looking shape.
Oh yeah, totally. and you can see your utilization, which is what I have the bottom set here for. The utilization is just off the charts. So it's no wonder we were getting these strange areas of just nothing in 2.4, because the non-Wi-Fi based interference was just causing massive problems throughout this entire side of the facility.
Yeah, basically it was keeping the access points from beaconing, so you couldn't hear.
Exactly. All of that important overhead that goes through wireless that helps you maintain your connection, the radios couldn't hear. And it was weird because it's kind of funny, because they would report to me that some days wireless worked, some days it wouldn't. Well, it turns out the days that it was working were the days that that line was down for maintenance or different things like that. So when we go back to our map, this line right here, as it turns out, it is an infrared curing machine. And the bulbs that actually generate this infrared, now granted, infrared is a completely different signal. It has no interference values as far as Wi-Fi is concerned. But the bulbs that generate this infrared, as it turns out, in their documentation, it actually states that they generate wireless noise in those spectrums. And nobody would have ever known that had I not done both the survey and the spectrum analysis to point them at that line. And so finally some guy went back and read the manual that was like sitting there collecting dust for however long it was. And was like, oh yeah, look, here we go, it's right here. And
wow.
so, that is just one small example. Well, actually, it's one big example of mechanical devices within a manufacturing facility that can completely just upend any sort of wireless communication if you don't know that they are there.
Yeah.
Go ahead.
No, yeah, funny enough, the question I had on hold was very super related. This is from Steve, and he was asking, do you see a lot of lights and ballast EMI? And I guess in this case, those light bulbs are were the cause.
These bulbs were. Now, I've had in other locations, I've had actual just standard mechanical drives creating frequency interference. So some drives do, some drives don't. I don't know the rhyme nor reason to why some do and some don't, and nor the fact that some will generate interference at 900 megahertz, but others will be higher up in the gigahertz frequencies. I don't know enough about how those variable drives work to be able to speak to that. But it's interesting, and it's common enough that every site that I go to, whether I feel the need or not, I go ahead and I do spectrum analysis, because I'd rather have that information and not need it than to need it and not have it.
Yep.
But it's great too, though, because these passive surveys can many times, like in this particular instance, give you that initial thought of, hey, something weird is going on here. We need to figure out what it is.
Yeah, yes, indeed. And this one is a very interesting one, because at first glance, you will think, well, there's just maybe no coverage, something attenuating the signal. But then you look at the 5 gigahertz, which normally doesn't propagate as well as 2.4, and it's like, okay, that's very, very weird.
Exactly. So yeah, and again, this just floored me. But I have been to several other sites where it may not have been this bad, but it's been pretty close. And again, it's all manner of different things. And this is why the realm of wireless in industrial facilities is so different than it is for doing office space. It's so different than it is doing for public education, higher education. It's just a completely different universe of complete different environmental variables. So we went back through, and I had long discussions with them, and they are now actually in the process of replacing their devices. And this particular place, all of their radios were actually several years past end of life as well, so there was no support available for them. So I went through and did a design for them, again, laying out attenuation zones and everything like that that made sense. This particular installation, because the radios were so high up, I did choose to go with Aruba radios. And again, for the mechanical down tilt aspect of them, and to stay away from the extra maintenance involved when using external antennas, especially in an environment like this. This is a high heat, high dust environment. The last thing I want to do is create more points of failure when I don't have to. So there's a myriad of different reasons to choose different radios for these different projects. Again, set all my my zones and the walls and all that fun stuff. And I ended up with 5 gigahertz coverage that was a little more solid than theirs. This has been installed and validated, and they are very happy with everything that's going on now. Their move to 5 gigahertz has definitely corrected all their issues. And I was really happy with this project too, how it ended up turning out.
Nice.
So the last thing, I had 2 of them in there. The last thing I wanted to kind of talk about and take a look at, again, I do a lot of work in pulp and paper. Just again, there's so much of it in this country. I got to go play on a crane, and this was a lot of fun. They wanted to do a point-to-point for a crane to bring it back into their OT network. So I went and I talked to them, and the challenges I was looking at is this crane was massive. I mean, typically cranes aren't small, but I mean this thing is gigantic, and it was mobile. It actually was set on rails, so it would move back and forth. And this crane was designed to handle logs, giant logs, that would then move from train cars and various trucks into storage, and then take those logs and put them on conveyors where they would go to a chipper, a debarker, and then a chipper, and then turned into wood chips to be used in the pulp and paper process. The actual, so this sucker would move, 800-900 feet back and forth, which doesn't sound like much when you're just looking at a slide, but when you're actually there and see what that distance really is, that's a lot. The crane itself was about 75 feet high, 75 feet high. And then the building that we were going to come off of was approximately 14 stories up. So it was an additional, I don't know, 40, 50 feet higher than the actual crane. At its closest connection was about 450 feet. Its furthest was about 1,200 feet. So a little less than quarter mile at max. So the distances I wasn't too concerned about. The height change, well, after some radio research, the height change really didn't become an issue either. But it was interesting. So when you go and you look at, and this is just any paper facility USA, I mean, because they all have these similar things. This here is the crane. So it's this long blue boom essentially, and it's got 2 A-frames to either side, and it's on rails. And so it will go back and forth from here to here. And you can, if you look closely, you can see this is all wood piles here. And then, it dumps them off to wherever it needs to dump them off to. And so and this right here is what is called a recovery boiler, and every paper mill has these. And I won't get into a long explanation on those, but just suffice to say, it's a very tall building and it has roof space that we could use. So essentially, it had to be able to communicate with this entire area as this crane moved back and forth. To give you kind of a better perspective of what I was looking at, this is what it looks like from the crane point of view. So I was pretty high up there, and to be honest with you, this is one of the coolest things I've gotten to go climb on this crane. And it's interesting. On a side note, while on this, I did some spec-an while I was up there, and they were just installing some new variable drives in here, and these variable drives actually produced a significant amount of interference in the 900 megahertz spectrum, which several days later, some of their operators came and asked me. They were having some problems with some of their 900 megahertz radios after they were done with the crane maintenance work. And I was able to tell them, well, your new drives that you've just installed are what's doing it. So now they're looking at moving to a different frequency and getting new radios for that. So just another case of where electromagnetic interference is real and can affect everything. Anyway, so I spec'd out some outdoor radios for these, and the overall design was going to be this. I was going to have an Omni, an outdoor radio with an internal Omni here as opposed to external because of the elements and everything. And then a directional, a semi-directional on this side, 90-degree semi-directional. So that would actually cover everything. And I wanted to make sure that everything was going to kind of jive and maintain connectivity on this full track. So I was like, all right, why not? Let's throw it into Air Magnet and see what we come up with, right? Because one of the nice things that you can do in Air Magnet is you can actually adjust the angle in your simulation as far as the directional signal propagation. And so that's what I did. So it's kind of weird. It's kind of hard to tell on a color, you know, on a color overlay. But you can see most of it's all yellow back here. But the important thing is this section in here, and you can actually see the lighter kind of bluish and the lighter bluish here. What I was hoping to accomplish as far as simulation wise, it was showing me that I was right on target. And like I said, I was able to adjust the pattern by using the slider to the direction that I wanted to simulate. I do, because this is a live installation now, had their power set at 30 dB which is their max, to make sure we have strong, clear connection. And it's worked like a champ ever since. So nice. This was just a fun one that I wanted to go over real quick before I wrapped up.
Yeah, just in case, the photo you had where you can see the view from the crane all the way, that gives you a real perspective.
Yes, sir.
It gives you a real perspective of the stuff here. It's like, wow.
It's awesome. I mean, I get to go to a lot of these places, and I, you know, I mean, honestly, my job's kind of an episode of how it's made, because between pulp and paper and all these different manufacturing facilities I go to, you know, I learned so much about how different things are made, and it gives you a greater appreciation for everything that you have, and that you can just go buy at Walmart because you know what it went through to actually produce that item.
Yes,
but, you know, it's a lot of fun, you know. And this crane actually has a little elevator on it, but it's probably the scariest elevator you will ever ride on in your entire life, because you're all trapped into a one-person cage and it's a geared elevator, so it rattles the whole time that you're going up. Yeah.
Nice. Well, that's why we call this session awesome industrial environments. So if anyone was wondering why.
It's so much fun. It really is. You know, I mean, I don't know how else to explain it. So if any of you guys out there are looking to get into a more of an industrial wireless application specialty, do it. There's not a lot of us. We need more of you.
There you go, guys. If you're looking for a change and something cool to do, hey, industrial Wi-Fi network designs.
Absolutely. So, you know, thanks you guys for listening to me yammer on. I greatly appreciate it. I've had a really good time. It looks like I ran over a little bit. Sorry about that.
Oh, it's okay. Most people stayed, so it was a great session. A very super interesting topic. Here on the chat, we have people like, hey, great info, Scott. Thanks, NetAlly, for the webinar. Really neat. So thank you, Scott, again for your time today.
Absolutely.
I know, yeah, and it was a super great information. I apologize, everyone, again, for running a little over, but since you're all here still, that means that it was worthwhile. So that's good to know. And well, regretfully, since we ran over, we won't have any more time for final QA, but we already had a lot of questions, so I think that will be okay. And anyway, guys, thank you very much again for joining us on this month's Tech Chat.
We're just gonna have to do it again.
Oh, yes, indeed. Yes, indeed, Scott. That's what I was going to say. I hope you will join us again.
I would absolutely love to.
Yeah, that's how we
especially once I get a chance to put this little guy through its paces.
There you go. Yeah, I want to see how your results look like in there.
I do too. I do too.
Okay, guys, so thank you very much and well, I think that's it for today. We'll see you all again next time.
See you later, everybody.